Alright, this is motion, speed, velocity, and acceleration, part 2. We're going to skip ahead to where we were at the end of part 1, which is where you were doing a paper about a spider moving on a wagon relative to Tommy. And you put your name on that paper and you turned it in. And now we're moving on to part 2. Let's take a look at these units right here, miles per hour. Alright, not mph, by the way. That is not the scientific way to write miles per hour. mi/hr, not m. M, like this, that stands for meter. It does not stand for mile. Alright? Not capital M. Okay? Not mm. Just mi is our units for hours, for miles. Alright. What other units could we use to measure speed? We can measure speed using any distance unit divided by any time unit. We talked a little bit about this last week. So, for instance, meters divided by second measure speed, but so do centimeters divided by seconds. And so do miles divided by seconds, and kilometers and feet. So there you go, kilometers per second. Or it could be kilometers per year, or it could be kilometers per minute, or kilometers per hour, or feet per hour. Any of those are units that you can use for speed. Here are a couple of the most common ones. Kilometers per hour, and once you really get into physics, you'll find that you're almost all the time measuring speed in meters per second. You need this paper. If you haven't had this paper passed out to you yet, you need to pause the video and get this paper passed out. Alright, now that the paper has been passed out, let me tell you a little bit what it is. This is a chart of units. These are units that you need to have memorized. So over here, we have, in this first column, we have the quantity. That's the thing that's being measured, like distance, time, speed, or velocity. We will talk later about what the difference between speed and velocity is, by the way. Acceleration, force, etc. Here's the abbreviation. So D is the abbreviation for distance. T is the abbreviation for time. Speed is abbreviated with an S. Velocity is abbreviated with a V. And these are the possible units that you can use to measure those quantities. So distance can be measured with meters, kilometers, miles, feet, inches, centimeters, etc. And here are their abbreviations. Time could be measured by years, hours, minutes, seconds, etc. And here's their abbreviation. So these things are important. You want to memorize these things. How much of this should you memorize? Well, for now, you want to memorize down to that red line. So mark that on your paper. Alright? The sooner you memorize these things, the easier this class is going to be for you. You want to have these memorized within a day or so, if possible. Flashcards are great. Alright? But get this done, get these memorized. Alright? And we're going to talk as we go about how we use these. Will you ever have to memorize the ones down here? Yeah, you will, just not yet. Those will be later in the year. Alright, we are going to talk about next the difference between speed and velocity. And to do that, we have to define two other words, which are distance and displacement. So, Little Red Riding Hood is going to help us tell a story to help us learn the difference between speed and velocity. So this is Little Red Riding Hood at her house, and over here we have Grandma Hood's house. And Little Red Riding Hood is going to go visit Grandma. So la 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 la. Alright, she has gone 2 miles, and she is 2 miles away from where she started. So we would say the distance she's traveled is 2 miles, and her displacement is also 2 miles. Now it's the end of the day and she goes back home. La 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 la. Alright, now, what's the distance that she's gone? She's gone 4 miles. She went there and back. Displacement is how far away she is from where she started. What's her displacement? 0 miles. So even though she traveled a distance of 2 miles, her displacement, I'm sorry, 4 miles, her displacement is 0 miles. Alright, what if the wolf is chasing her, and the path that she followed to Grandma Hood's house went something like this? Alright, what's the distance that she's traveled? Well, it's certainly more than 2 miles. It's probably more like 5 or 6 miles. But what's her displacement? Her displacement is 2 miles. Alright, so the wolf comes over here. The wolf waits and ambushes her when she comes out, and the wolf chases her back home. Alright, what's her total distance been that day? Well, we don't know exactly, but it's probably something like 10 or 15 miles. What's her displacement? Her displacement is 0, because she's back where she started from. Distance is different from displacement. Alright, distance is what you think it is. Displacement is how far you are from the starting point. Speed is about distance versus time. Alright? Velocity is about displacement versus time. Velocity always includes direction. It might say north, south, east, or west. It might say away. It might say toward. That's a good way to make clear what your direction is, and sometimes we just use it with pluses and minuses. Alright? This is a good thing for you to write down. So I'm just going to pause this while you get out some notes, and I want you to write down what we have up here at the top of this paper as far as these 3 definitions. Alright, so hopefully you've written those things down now. In physics, that you might take as a junior or senior, this is going to be a lot more complicated because we'll deal with situations where people take different paths and they come back where they started, so the distance and displacement will be different. In this class, though, with you guys as freshmen, almost every single time we solve a problem, we're going to solve a problem where something just goes in a straight line and then it stops and it doesn't come back. So you're going to be dealing with problems where distance and displacement are the same. So that means that in the math problems that you solve for me, your speed and your velocity are going to be the same. The only difference is with your velocity, you want to indicate the direction that the object went as part of your answer. So again, you might have a multiple choice question that asks you the difference between speed and velocity, but in the problems that you solve for me, they're pretty much always going to have the same magnitude. Alright, now we need to get into the problem solving. So we're going to have to stop this tape in just a second and make a part 3 because I can only upload 15 minutes at a time. Alright, but this is where we're coming. We're going to be working with these definitions. You're going to want to write down these equations before we move on to part 3. Speed is distance divided by time, and that is how we write the formula with the abbreviations. Velocity is displacement versus time, and that is how we write the equation. Sometimes you're going to have problems that say, what's the speed of blah blah blah, or what's the velocity of blah blah blah. But sometimes you're also going to be asked to solve for how long it took an object to do something, or what the distance it traveled was, or what its displacement was. And we will do part 3 to cover that material. So write these things down, pause, write these things down, and then we'll move on to part 3.